Hi all, this is the Pro Motory channel. Today we're going to take apart this engine. This is a MAN D2866 model LF06. The engine was removed from MAN truck tractor. I don't remember the model right now, but I insert a photo of it. What's the reason for removing it? Let's call it scheduled maintenance. Nothing is knocking, nothing is rattling. Basically the engine is running fine. But there are a few small issues, a few minor nuances. Let's say we blew the gasket between the 5th and 6th. But usually if it's between the 5th and 6th, then most likely it's the 5th cylinder. And it usually blows out toward the exhaust valve. And here's something else we noticed when we were taking this engine apart. All the air manifolds, all the air pipes, they're all clogged with dust. So somewhere besides the air filter, it was taking in dust. This is a common reason. It's a common issue with these engines. Well, actually not just these, but in general. It's late and dark now, but tomorrow I'll probably show the reason why dust got into the engine and I'll add the footage. Either the hose or filter isn't original or someone didn't install it correctly. Since we saw dust in the air intake manifold, we can already make some assumptions about the engine's condition. We can already assume, for example, that the rings or sleeves might be worn out. Let's not guess. Let's take it apart and see. I've already washed this engine. It's probably as clean as it can get. I spent nearly an hour on it. Some spots still have dirt and oil left. Anyway, after disassembly, every part, every detail will have to be washed separately. Washed, clean and so on. So, to start with, I'll remove a bit of all these attachments here. By the way, they broke the tip here when they were taking it off. But we'll replace it. It's not a big deal. First I'll take off all these little tubes, hoses, these brackets and so on. Then I'll remove the gearbox and take off the clutch. What else do I want to show? What point? We can see that the gear shift shaft, the gear selector shaft is worn out. Look at how much play there is. As usual, this is a common issue with all ZEF gearboxes. Here we have a 16-speed gearbox. 16S151. Well, maybe I'll talk to the owner. Maybe we'll drain the oil and take a look. If the oil has water in it, if there's water present, then maybe we'll do something about it here. But for now, these are just thoughts out loud, you could say. There hasn't been any conversation yet. So basically everything is as usual for us. We disassemble, check for defects, order new parts, send some items for repair, fix others ourselves, then reassemble and start it up. I don't know about painting yet. There hasn't been any discussion. Maybe there'll be painting later. I removed the gearbox, took off the clutch, and I'm draining the oil. What do we see with the clutch? We see that the disc was replaced not long ago, so a new disc was installed. We can see that there's contact here, but not here. So this part isn't working yet, it hasn't worn in. This means that only the clutch disc was replaced, while the pressure plate and flywheel are still old. So I'll check with the owner. If there were no issues with the clutch, we won't touch anything. We'll just clean everything, blow it out, and leave the old disc, old flywheel, and old pressure plate. The flywheel also looks to be in good condition visually. There's no noticeable wear. Of course, the bearing will need to be replaced. Now, looking at the oil, we see that the level is as it should be, and the oil itself doesn't have any emulsion or metal shavings. Basically, it's normal oil that's already been used. That's it, I've drained the oil. I'm screwing the plug back in and bringing the engine to the table. But I'm starting to disassemble the engine. I've already brought it to the workstation. I put the table away for now because the oil pan is very tall. So the valve covers are about at the level of my head, something like that. For now, I'll be taking it apart in this position. Later, when I lay it on its side, I'll set up the table. I'm starting the disassembly. I'll record everything in time lapse. Let's go. I removed the intake manifold to inspect the air channels and found oil in the first and second cylinders. Here's the breather outlet. The breather may have thrown oil. On the third cylinder we see oil, but further on it's just dry dust. In the fourth cylinder we can already see dust on the walls. The fifth one as well, you can see dust on the walls, and the sixth cylinder too. Now let's take a look at the intake manifold. We can also see that the first, second and third are covered in oil. But for example, on the fourth cylinder, it's clearly visible that there's dust in the manifold. This is our fourth cylinder and this is our fifth cylinder. On the fifth cylinder we take a look, and here's how much dust and dirt we have in the manifold. So definitely we have dust present in the manifold. Alright, I unscrewed the rocker arm, removed it, took out the push rods and removed the injectors. First, I'll spray them so they loosen up a bit. Alright, I removed the cylinder head covers, and what do we see? The first thing we see is a burnt gasket on the fifth cylinder towards the exhaust valve, just as I said. This is our sixth cylinder and this is our fifth cylinder, and we can see that the gasket here is black. We can see that it burned out towards the exhaust valve just as we suspected. What's the next thing we see? The cylinder heads have been on a surface grinding machine. That was actually quite recently. So you can see that the heads have been ground, which means everything here is basically fine. I think this time we won't need the surface grinding machine. Next, what else can we see? I've already measured the protrusion of the liner above the cylinder block to see why exactly the fifth cylinder burned out. Okay, well, the block is dirty, so we're looking at it approximately, give or take. This is roughly 0 for us. 10, well, 200s, 10, 200s, 10. Basically, we can see that, well, I didn't measure everything, they're all dirty here. It's impossible to measure anything in this kind of dirt. I cleaned just this one spot. Basically, we can see that the sleeve has an 800s protrusion, which is basically how it should be. So it's not even clear why the gasket burned out, right? The block is in good condition, the heads are ground, and the gaskets are good. I was filming with that camera on the tripod like this, but I'm not sure if it was visible. I was loosening the heads almost without a pipe. There was no cracking, no crunching, nothing at all. So I was loosening the heads without any effort. Usually, I loosened the heads with this pipe and with a characteristic cracking sound. As a suggestion, I'll say it's just a suggestion. The person was tightening these heads, but let's say the wrench wasn't calibrated, or maybe it was off, the setting was off or something else, and as a result, the tightening was done incorrectly. The heads were only tightened halfway. That's my first assumption as to why the heads came off so easily and why the gasket on the fifth cylinder was blown toward the exhaust valve. It's possible. So that's my first assumption. Here's my second. We can see that the cylinder head bolts are not original anymore. That is, it's clear that new ones were installed. There's a symbol here, but it's unclear what it is. So it's possible that after tightening, these bolts just stretched. They elongated, and as a result, they no longer hold properly. I'll clean them to check what brand they are, measure them, and maybe even replace the bolts if needed, or maybe I'll find some old original ones I have, but not these ones. So I have two theories about why the gasket and the cylinder head burned out. We can also see that there's carbon buildup here, some pretty solid deposits. This is probably where oil was burning. Let's keep disassembling. Now we're going to remove the fuel pump. Now let's line up the marks and take a look. Unscrew this inspection window. We look inside and we see the mark appear. We set it in the middle of this hole, and now we check the marks on the flywheel. I didn't see anything on the flywheel because it's all covered in dirt, dust and so on. I'm marking the flywheel's edge. Then I'll check it after removing the flywheel. Alright, this is how we make the mark. And when I remove the flywheel, I'll check how many degrees there were. That's it. Now we can remove the fuel pump. I turned the engine over, laid it on its side, put it on the table, and now I'm removing the oil pan. Next, I'm removing the pulley, the flywheel, and the flywheel housing. We can see the rear oil seal was leaking. It's wet around it. The seal needs to be replaced. I took out the camshaft and right away you can see a chipped cam lobe. You can see it with the naked eye. It's got a low height. You can immediately tell the cam lobe is chipped. The camshaft definitely needs to be replaced. That's for sure. If we look at all the cam lobes, they're all in this condition. So the camshaft definitely needs to be replaced. And as you can see, the lifters are in bad shape too. The lifters also need to be replaced. And of course, the camshaft bushings need to be replaced as well. I'll just say this quickly now, because I'm already tired as a dog. It's 10 minutes to midnight. There will be some kind of update tomorrow. The cylinder liners need to be replaced. The main and connecting rod bearings need to be replaced. The piston rings need to be replaced. The lifters and camshaft need to be replaced. As for the crankshaft, I don't know yet. There's some play in the bearing. The journal may already be undersized, but this needs to be checked. The fuel equipment definitely needs to be repaired. That's the pump and injectors, and basically what else can I say? We'll be repairing the compressor, and the cylinder heads will be disassembled. Possibly there will be replacement of bushings, replacement of guide bushings, and replacement of valve stem seals. Well, so as usual, we won't be taking them to the machine shop either. These are just preliminary results. Tomorrow I'll still record a bit more video, but for now that's all. So let's continue. What else can I add besides what I said yesterday? Yesterday evening, when I checked the pistons, I thought they looked fine. But today, with a fresh mind, I looked again. On 3 pistons we can see these kinds of scuff marks. Here we see a scuff on the skirt of one piston, on the second and on the third. Some are bigger, some are smaller. These 3 pistons are in better shape, but they have similar scuff marks. The current question is whether just these 3 pistons will be replaced, but most likely a completely new set of pistons will be installed. Well, I already talked about the bearings. The connecting rod bearings are in better condition here. The main bearings are worse. Basically, everything I mentioned yesterday evening still stands. Except now we have 3 more pistons added. So what do we have now? I took apart the turbocharger. We sent it for repair. There's also a small issue with the turbocharger. For example, we see a clamp that connects this inlet pipe. It was attached with this kind of clamp. As we can see, this is a plumbing clamp. And here, if you look closely, you can see 6872. That's the size. We can see there were some tuck welds made here. Basically, something was done here at some point, and in this spot there's also a lot of dust in the air manifold. So it's possible that air was also being sucked in through here, bypassing the filter. Here we can see how much dirt there is. We'll have to deal with this issue too, maybe. Well, actually not maybe. We'll need to get this clamp, but only the factory one, and replace this rubber piece. The turbocharger has already been sent for repair. The fuel pump and injectors have also been sent for repair. I've also already removed the sleeves, knocked them out. Next, I'll remove the seals under the sleeves, the push rods, and the bearings. I might also remove these brackets for convenience to make it easier to wash. And that's it. The block will be sent for cleaning. Alright, that's it. I took out the seals. The seals are pretty worn out, of course. You can see they've settled. They're not round anymore. Some are crushed and so on. Well, obviously the seals need to be replaced. Basically, that's it. The engine is disassembled. Only the block is left. Now I'm taking it to get washed, cleaning it up, getting it all cleaned. Now, a small addition to what I said earlier. First, all conclusions should be made after washing, after cleaning the engine, and in general any part. You should inspect and check for defects on a clean engine or part. That's when you make decisions and draw conclusions. First, after washing this block, I'll explain in more detail what's wrong with it. I'm not sure if you can see it now, but I'll add footage from another camera. As we remember, the cylinder heads on this engine weren't tightened. The heads came off very easily with a small wrench, almost without any effort. Here, you can see it starts almost from this side and goes all the way through the block, ending only on the other side. I've installed the block here. This is our 0 point and it's dropping into a dip. Well, in this spot it's 8 millimeters. Here, looking at the block, this is our 0 point, and in the dip at this spot it's 11 millimeters. Here as well, looking at the block, this is our 0 point, and in this spot it's dropping 7 millimeters. Well, if we move further this way it's 10. Here it's already 12, and so on. And now I want to show you with the feeler gauge. We place it like this and the gauge is 0.2. I'm showing the gauge 0.2. It goes through freely. That's how much the block is worn out in this spot. Accordingly, you can see here it doesn't go in. Here it doesn't go in either. It only slips through right here. It's either the bolts, they were poor quality and stretched, or loosening the heads, or the cylinder head bolts were tightened incorrectly at first. For example, I suppose it could have been done with a faulty torque wrench as one possibility. I offered the owner of this engine 3 options. One option is to leave it as is. Since the new sleeves are still in place and haven't settled, it will run for a while. Usually the period is about a year to a year and a half. The second option is to have the block machined where the cylinder head meets it. To what size? Make it about 2/10 smaller. What are the drawbacks of this option? Thought, first of all, it's expensive, and second, it takes a lot of time. Third, you'll need to find smaller repair pistons. They have a compression height that's 2/10 lower. That's also a problem. First, there might be a problem with the delivery time for these pistons. And the second problem could be the price. Remember, this engine repair is limited by time and budget. Well, and the third option is to replace the block. That is to look for a similar block in good condition somewhere and just swap it. We'll probably choose the third option. We're still considering it, but that's the most likely choice. I also want to show the cylinder head. When I was disassembling, I mentioned that they are machined and that nothing needs to be done with them. Again, those were hasty conclusions. And when I washed and cleaned them, you can see there's a ridge all around the diameter where the sealing ring for the gasket sits. I'm disassembling the heads to send them for surface grinding. I've already done 3. Basically, the valves are more or less in good condition, but I'll still have to machine the working bevel on the lathe and lap them. The seats may be good, but we'll see. I'm taking apart 3 more heads now. This is how I take apart the heads. We check their condition and make sure the seat doesn't spin. We can see there are cracks on the partitions here. Well, that's a common problem with MN heads, and it's very hard to find a head without any cracks. If there was no gas in the cooling system, then you don't need to pay attention to these cracks. Well, as I said before, we'll grind and machine the valves, the seats, and so on. That's how I disassemble the heads and send them to the machine shop. So there will be fewer recordings than, say, in the previous series, because I'm limited on time. I only have about 10 to 12 days for this engine. That's why I'll only be filming the most interesting moments, but all the same work will be done, of course. Now we're starting to assemble this engine. We now have a different block. In the last episode I explained what happened to the old one. We chose the third option. This is a new block. I've already washed it a bit and cleaned it. Next my task is to go over all the threads. Now I'll run through all the threads on the block. I'll clean the top here too, since I plan to paint it, removing more rust and old paint now, well, as usual basically. So I already have some parts and we're still waiting for some others, including a new camshaft. Some work has already been done. We've already taken the cylinder heads to the surface grinder. The turbocharger is already ready. Basically, I'll be showing and explaining everything as we go. I'll also mention, I talked about in the last episode, I didn't explain the whole situation. I'll explain briefly in a few words that I'm limited on time. The person came to me for repairs, you could say by chance. There were no plans at all. I had made arrangements. I had plans to repair a 10-cylinder engine. But since I was counting on repairing the 10-cylinder engine, I didn't take on any other work for the time being. Then, when I realized that the person disappeared, I started looking for other work options. And with the person, the owner's name of this engine, the owner of this car is Anton, I got in touch with Anton. Well, actually, Anton asked me how much it would cost to repair the engine, and I answered him. He said, well, I need to plan to come to you for repair sometime. I said, well, I have some free time right now. If you want, you can come over. We had this conversation on Saturday, and by Monday evening, they were already removing the engine. So, people were already working, the car was on the pit, and the engine was already being taken out. By Wednesday evening, I had disassembled the engine. That's how fast it all worked out. But let me remind you, we're limited on time. By early February, around the 10th or so, the engine has to be ready. And not only ready, but already installed in the car. That's why I'm limited on time, and the filming won't be as detailed as, say, the previous series, but I'll try to film as much as I can, depending on how it goes. The engine's owner didn't expect repairs and has a tight budget, so we're making some decisions. We're seeking a middle ground. That's how things are, so let's start preparing the block. I'll also add that this car is currently here in our pit, but actually it was bought in Perm, and it's going to Altai. So my previous engine was from Buryatia. This engine is from Altai. block is fully prepared. The block is completely ready for assembly. I cleaned it, removed all the dirt, rust, old gaskets, and so on from the outside. I chased all the threads in the block, cleaned the oil channels, removed, blew out, and cleaned the injectors. By the way, the oil injectors here are a bit different, so the block is fully prepared for assembly. I'll start with installing the camshaft bushings and the camshaft itself, although I don't have it yet. We're still waiting for it, so today it's still just preparation work. I'll probably move on to the crankshaft next. I'll get the crankshaft ready. I've polished the crankshaft. You can see how it looks now. Completely different. What else do I want to say? After clamping the machine and wiping it down, I noticed a mark. BF casting. This crankshaft isn't the original from the factory, so it was replaced before. I don't know why or when. Well, basically we can see that this crankshaft isn't new anymore. There's even a bit of wear on it already. I'll explain now. So it has already been used in this engine. Let's hope that it will continue to serve us well, work properly, and last a long time. About the wear. The connecting rod journals all measure 89.98. I just measured all of them. On this one, we even see 89.99. So all the connecting rod journals are within the normal range. As for the main journals, basically the 7th, 6th, 5th, and 4th are all around 103. 97.5, literally about half a hundred, you could say, below the size. And the first one is also within the normal size. The second main journal and the third are below the size. The biggest unders is on the third main journal. The size here is 103.96, which is 200 below the lower limit. We're not going to do anything about this since there's nothing we can do anyway. Well, if we grind it down to the repair size, it'll be even worse. Repair bearings on these engines usually don't last. So it's better to leave it as it is. Alright, the crankshaft is ready, polished and measured. I just removed another washer. I'll put on this new thrust ring for the oil seal. And basically, well, I'll also blow it out. Blowing it out is a must. And basically, the crankshaft can be installed. And I'll mention one more thing, there are intermediate repair bearings. For those who know, there are intermediate repair bearings, which means you can install them without grinding the crankshaft. For this engine, the intermediate repair bearings for this crankshaft come in increments of 1/10 of a millimeter. There is such a size 0.1. The block is ready. We'll install the camshaft, which arrived today. They brought the camshaft bushings today, so we'll start assembling soon. I've done most of the prep work, some parts aren't finished, but we'll begin assembly anyway. During the engine assembly, we'll be taking breaks for some preparatory work. Now I'm unpacking the camshaft, installing the camshaft bushings, and installing the new camshaft. camshaft bushings are in place. Now let's check the oil passages. The camshaft bushings are installed. I checked the oil passages, everything matches, everything is fine. Next, I installed the new lifters and then the camshaft itself. I also prepared the gear, the compressor drives and the bolts. I installed the lifters, installed the camshaft, and already attached the compressor drive gear. I turned the engine over. Next, I'll work on the new piston assembly, which includes the sleeve, piston, rings, and pin. One cylinder was unwrapped. I checked if it was the correct piston and verified everything. We're unpacking the piston assembly, installing sleeves, and attaching pistons to connecting rods. Alright, I've unpacked the piston assembly, took out the pistons and marked each piston and sleeve. Now I'm going to weigh the assembled pistons, the piston rings and pin. It's 3588, 3592, 3594, 3591, 3588, 3589. We see 88 and 94, that's a difference of 6 grams. Well, we're not even going to take that 6 gram difference into account. So our pistons are all perfectly balanced by weight. Next, I'm working on the sleeves. The flange height on all sleeves is 10.07. We install the sleeves without the adjustment ring and measure the protrusion. I don't think we'll need the ring. I've installed the sleeves and measured this one. It's about 7 or 8 hundredths. Now we're measuring the 5th sleeve. I've tightened it with my homemade clamps and let's see. We see the block is at 0. The sleeve is at 807. The block is at 0. The sleeve is at 8 hundredths. Looking again, the block is at 0. The sleeve is at 8 hundredths. 0.8 hundredths. Alright, and let's look. In the 3rd plane we also see the block is at 0, the sleeve is at 8 hundredths. We see the sleeve protruding above the cylinder block. The 5th sleeve is 0.08 above, and similarly I check all the other sleeves. measured the sleeve protrusion. All are around 7 to 8 hundredths, which is normal. I took out the sleeves and now I'm going to put them on the rubber seals. The rubber seals are L-ring, just in slightly different packaging. These are specifically MAN ones without the adjustment ring. As you can see, we have two thin rings here. I've installed with one rubber seal, with two rubber seals, and even used sealant. Basically, I've tried different ways, and in every case, everything works fine. We unpack the seals and install the sleeves in the block. I've installed the sleeves. When the rubber seals are well lubricated, they go in easily. You can see the sleeve is sticking out just like all of them. The upper rubber seal is installed, so you can't press it down now. Once the cylinder head is installed, it will push down on the seal. Alright, the sleeve is in. Now I'll flip the block and install the crankshaft. The sleeve is installed. I set the block on its side again and lifted it slightly. In general, I prepared it for installing the crankshaft. The crankshaft is also already prepared. Now the only thing left is to blow out the oil channels with air. I prepared, washed and cleaned the caps, installed the bolts and greased them under the head and on the threads. I prepared the bearings. Now we're unpacking the bearings, blowing out the crankshaft, installing the bearings and installing the crankshaft into the block. I unpacked and installed the bearings as usual. The bearings with oil channel holes are installed in the block. Eek. The solid bearings are installed in the cap. Eek. The only thing I forgot to mention is that I still don't have this thrust ring for the oil seal. I removed the old one but haven't got a new one yet. I'm installing the crankshaft now and we'll add it later. No problem. I wiped the crankshaft and cleaned out the channels. Now I take the assembly paste. I lubricate it with the assembly paste and install the crankshaft. The crankshaft is installed and tightened. Everything turned out well. Everything is great. The axial play is also within the norm. I measured it 0.1500. I removed the old pistons and now I want to show you an interesting point. We can see that we have 5 pistons. These are still factory ones and 1 piston has already been replaced at some point. We don't know the reason for that. 1 piston was replaced. Now we're weighing them. For example, let's take an old piston. We see its weight is 366 grams. Let's take the second old piston, 366.2 grams. I weighed them all and each is about 366 to 366.5 grams. The difference is about 5 grams. Now let's look at this piston, which was replaced earlier. Its weight is 363 grams. The difference there is almost 60 grams. This piston alone is 60 grams lighter than all the others. And yet, basically, they didn't pay attention to this during assembly. Well, maybe they just didn't wait, possibly. It didn't cause any critical consequences. Of course, all this could have led to something, but I'm just showing the fact that the piston is 60 grams lighter, and yet the engine worked. This is about the maximum allowable weight difference between pistons. We'll now install the new pistons on the connecting rods, wash the rods and assemble them. I have installed the pistons onto the connecting rods. I have already prepared the bearings. We have sputter bearings because the engine is turbocharged and the size is standard. But before installing the bearings, I want to remove the piston rings from, let's say, the 6th cylinder and measure directly in the cylinder liner what the thermal gap will be on these rings. We can see that on the oil control ring, the gap is 0.25 millimeters. On the compression rings, the gap is 0.45, which is basically within the acceptable range. All the pistons are installed and all the connecting rods are already tightened. That is, the main connecting rods are fully tightened. I checked how the oil nozzle fits into the recess. Everything is great, everything is fine. There's no misalignment, nothing is getting stuck anywhere. I also want to show that all the main bearing caps are marked. That is 1K408, 2K408, 3K408. We can also see the number on the block itself, 3K408 and so on. 4, 5, 6, 7. And the connecting rod itself, both the rod body and the rod cap are marked. We see I458. On the cap it's also I458. Here we have I490. And on the cap it's also I490 and so on. It's impossible to mix up the caps. Alright, the pistons are installed. The connecting rods are tightened. Now I'll start installing the counterweights.
The counterweights are installed and tightened. The crankshaft main bearings, connecting rods and counterweights are all fully tightened.
Alright, we're done with the crankshaft. I prepared the rear cover, I prepared the front cover, washed and cleaned them, placed the threads, I removed the old gasket and replaced the seals. We're using O-ring seals. I also replaced the flywheel housing seal and checked all the threads there. I'll install the rear cover now, but can't add the front cover yet since I don't have the thrust washer. Currently, we're working here. I'm installing the cover and maybe the flywheel and clutch. The cover is now installed and tightened. Next, I'll install the old flywheel, clutch basket and disc curocles. Basically, it's in good condition. And the car owner had no complaints about the clutch. The only thing is, the bearing will be replaced with a new one. The release bearing will also be replaced later, but that will be when we install the gearbox. Release bearing, alright? Now I'm installing the bearing, the flywheel. I'm installing the flywheel, and then the pressure plate, and the disc. I prepared the input shaft and the bolts. We continue assembling. I've installed the cover that closes the compressor drive gear. I'm still waiting for the thrust ring for the oil seal. It's a small part, but it's holding up the work. I can't install the front cover, I can't put on the oil pan. In the meantime, I've already disassembled the compressor while waiting for this washer, and I've already started repairing the cylinder heads. The cylinder heads went through the surface grinder and look great now. I've already leaned the valves, washed and cleaned the heads again after the machine blew them out and removed all the dust. I've rimmed the valve seats already. The working surface is in good shape, so I won't touch it. I've already machined all the valves and I've already lapped one cylinder. That's the 6th one for us. It doesn't matter which one it is now, but the marks say it's the 6th. We can see there's already an imprint from the seat on the valve, and we can also see it on the seat itself. For example, on the 5th one, before lapping, the seat has that characteristic metallic shine, almost like a mirror. But after lapping, it becomes a bit matte because the paste doesn't polish it to a shine. Our main goal is to ensure the geometry stays intact. Alright, that's it. Now I'll lap all the remaining valves. I won't show that part. I'll show the cylinder heads when they're ready. Lapped all the valves. You can see that all the valves have a track from the seat. Everything lapped well, everything's great. This is how the seats look now. I washed the cylinder heads here with solvent, blew them out, washed and wiped the valves as well, repaired the springs, repaired the washers, repaired the keepers, and got new valve stem seals ready.
Alright, now I'm assembling the cylinder heads.
Alright, the cylinder heads are fully prepared for installation. While I was working on the cylinder heads, they brought the washer for the oil seal. Now I'm installing the washer, putting on the cover, and I'll try to close the oil pan today. Next, I'll install the oil pan. I prepared the plate and the gaskets. I opened it up at least to visually check the condition of the oil pump. Here, basically everything is fine. Well, obviously there's some wear on the shaft and on the gears themselves, but okay. So now I'm putting the oil pump back together, installing the pump and closing up the oil pan. I lifted the engine a bit, put some bottles underneath, checked with the detector, the engine over again, made sure nothing was in the way, nothing got in there, and so. We're going to close up the oil pan first. We install the gasket, then this intermediate plate, then the oil pump, then another gasket, and only after that the oil pan itself. So the pressure relief valve is new. The oil pan is installed and tightened. So that's all for today. Tomorrow we'll install the cylinder heads. We're still waiting for the fuel pump and have compressor issues. Past that, the bearing will take a while to arrive. Alright, the oil pan is installed. That's enough for today. The cylinder heads are ready, and I showed how I did it. I also prepared and chose different bolts. We won't experiment, I'll use proper German bolts. I've prepared the guide sleeves and the gaskets. Now, I'll blow out the cylinder heads once more, and also blow out the cylinders and pistons inside. I'll wipe them a bit, blowing out and wiping. First I install the guide sleeves, then the gaskets, and then I install the cylinder heads. cylinder heads are tightened and everything's good. These real bolts let you feel the force. It's satisfying to tighten them. But those new ones, for example, they're like plasticine. You tighten it, but it keeps turning. Press it again and it still turns. And you can keep doing that endlessly until it becomes hourglass shaped. But these bolts, you can really feel the resistance when tightening them. From experience, old German ones are better than new ones from some unknown brand. No, if you buy new ones from a good brand, which will cost, I don't know, a few thousand rubles for one bolt, then yes, I agree, they will also be of good quality. Those bolts cost 150 rubles each and are terrible. My bolts are tightened and cylinder heads installed. I still need injectors, but I don't have them yet, so we're waiting. I'll figure out what else to do now. I'll install the rocker arms, the push rods, the rocker arms, and adjust the valves. I'll do that for now. Alright, the heads are tightened. Next I'll install the rocker arm shafts and push rods. I've already checked the rocker. Once washed them, blew them out, cleaned them, checked everything. So the rocker arms are ready. The push rods are also clean. I checked them for bending. In general, everything is ready. I'm installing the... I adjusted the valves and immediately closed the valve covers. I washed and cleaned the valve covers, resurfaced them on the machine. I prepared the bolts and the gaskets. That's it. I closed the valve covers. For now, I covered it with this piece of cardboard and secured it with 2 bolts, just in case something falls in there. I am still waiting for the injectors. While I wait, I'll repair the pump. It's still on the shelf and hasn't been cleaned, so I'll take it out, clean, rebuild, and install it. I rebuilt and installed the pump. Then I'll install the thermostat, the cover here, and another fitting. Well, later I'll assemble it here for now. Next I'll install the pulley. Next, I'll install the high pressure fuel pump. It was taken for repair or something like that. They tested it on the bench and said it needs repair, specifically replacing the plunger pairs. We calculated that it would take about 110 or 120,000 rubles to repair this pump. But let me remind you, this repair wasn't planned. So the owner of this engine is on a tight budget, and that's why he refused to repair the pump. So they adjusted it somehow, did something to it, but still said that the plungers need to be replaced. You might say, I'm installing a faulty pump now, so the owner will eventually need to fix it. What am I doing? I just unscrewed these bolts. Now, I'll install it to set the ignition time into 15 degrees. The manual says 14, but I'll set it 1 degree earlier. I unscrewed these 3 bolts and checked the tightness of these 13 bolts. I left one for now. Now I'll install it, set the mark, and then I'll put the pump on the engine with a new gasket. Here we can see 10, 11, 12, 13, 14, and here is 15 degrees before top dead center. Compression moment on the pump. In this inspection window there's a little plate, a tab. That's it, the pump can be installed. So I moved the pump a bit and now we can see the mark is right in the middle. It shifted a little bit in these 2 bolts. Now I'm taking out the pump, tightening the lower 2 bolts, and then installing the pump onto the sealing ring. Alright, the pump is installed and tightened in these bolts, and here's the additional bracket. The 4th bolt, the 4th bracket here, just has a stud without a nut. As usual, no one puts it there because it's nearly impossible to unscrew later. Let's check the mark again. We see that the tab is exactly in the middle, and on the flywheel we have 15 degrees. That's it, the pump is set. Now I'll tighten this plug and start installing the injectors. Next, we'll install the injectors. The injectors have been repaired. The nozzles were replaced. 2 nuts were replaced. These ones on 2 injectors. And these inserts were also replaced. The injectors have been repaired. The washers are new. The nuts are old. I washed them, cleaned them, and got them ready. A guide fell out of one of the injectors. I'll try to put it back in now. It's hard to install the injector without it. I'll spray the injector itself with copper grease, and I'll use ceramic paste on the nut so it doesn't seize up and comes off easily next time. Next I'm installing the return line and the high pressure lines. I've washed, blown out and cleaned everything. We'll use new bolts. The return line bolts are new. I'll show you the old ones. A standard 6mm bolt with one side of the thread ground down for diesel flow. I've done that sometimes too when I didn't have these bolts on hand, but now we'll have all new ones. The washers for the return line are also new. Now I'll anneal them, cool them in water to soften, then install everything. I once showed this process in one of the episodes. Annealing copper. Many commented, questioning the purpose since it would harden anyway. But for copper, this process is different. Instead of hardening, it makes it much softer. You can see how pliable it has become. It's really soft now. I installed the return line, pulled the tubes of the bracket from that block, tightened it, and that's it. Now I can install the air manifold. The air manifold is already prepared. As you remember, there was a lot of dust in it. I washed everything, cleaned everything, threw everything out. I washed it as much as I could. I prepared the gaskets, prepared the bolts. Let's install it. That's it, I installed the manifold. Here I also have the fuel supply hose attached. I installed the breather mount fitting and I'm now installing the old 79-degree thermostats with new gaskets. I installed the manifold and handled a few other minor tasks. Let me explain the situation with the compressor. The compressor is still disassembled. We don't have the bearing yet, so we're waiting for the bearing. And it'll probably only arrive around the 9th or 10th. By the 12th, the car should be assembled and ready. If we wait for the bearing before assembling the compressor, it'll already be the 11th. Well, that's not an option. So what will be done? The engine will be installed without the compressor. I made a plug for this spot here just out of cardboard for now. I don't know, maybe I'll cut one out of plywood tomorrow. We'll see. The engine will be installed without the compressor. I'll also paint it now without the compressor. Well, I'll paint it with this plug in place. And then when I assemble the compressor, well, basically, people will install it as they go. By that time, I'll have assembled the compressor. We install it on the spot. That's how it is. There's no time for a test run on the table. I'll try to film the startup on the car, but we'll see how it goes. Since everyone has their own work and schedules may not align, I'll try to film it in the car. I'm curious too, but I can't make promises yet. I'm installing the engine, standing up and prepping it for paint. turned the engine over, removed the table, and put it on the pallet because it's really tall on the table. It would have been taller than me. Next, I installed the heat exchanger, and now I'm installing the filter. Next, I'll be installing the manifold and the turbocharger. I've prepared the manifold and cleaned it. I found a crack here, but we decided to leave it as is for now. The turbocharger just came back from repair. We sent it out for servicing. It was delivered like this in the packaging, and we haven't unpacked it yet. Let's continue. I've prepared the engine for painting. Put plugs everywhere. Cover the threads and plugged everything here. I'll paint the filters too, since they'll be replaced later. For now, they're just acting as plugs. Here I just covered the mounting spot where the gearbox sits. Getting paint on the clutch basket isn't a problem. I covered the manifold like this with tape. I'll be able to paint these spots at an angle like this. I also taped everything off here. Basically, everything is ready for painting. I'll start painting with primer. The primer is acrylic, and then I'll use automotive enamel. The automotive enamel doesn't need a hardener, it just air dries. And there's a thinner for this enamel. If anyone asks why I'm using this paint, it's just because that's what I got. I'm not in charge of purchasing. We'll use whatever they brought for paint. The color is gray 671, which looks like this. Now, we're starting with the primer. That was the primer. This is how it looks now after the primer. And now I've mixed the paint. Well, I think there won't be much difference in color. The only difference is a glossy finish. The color is nearly identical. I'll show you again. The paint we're using is called Gray 671. This is an air drying automotive enamel. I thinned it a bit with this thinner diluent. Well, I think it might be a little thick. I'll try it now. If it's too thick, I'll add a bit more. Alright, let's start painting. new. I removed most of the tape, but left some in a few spots. Here on the turbo, we'll take it off right here. I installed the starter and I'm about to install the gearbox. I wanted to replace the release bearing because even though it shows no wear, it was turning very stiffly. I soaked it in diesel and worked it in. Apparently, some dust got in there. It spins perfectly now. I greased it thoroughly. That's it. We kept the old release bearing. I've already installed it on the clutch cover, the pin. Basically, some stay on the clutch cover, some need to be installed on the sleeve, depending on the fork. On this fork, the bearing stayed on the clutch cover, so I'll install it the same way. I also cleaned and lubricated the sleeve. I installed the bearing and fastened the pin. We're keeping the entire old clutch, the flywheel, the clutch cover, the disc and the bearing. The only new part is the small thrust bearing, that's in the flywheel. me turn it.
Thank you.